Demystifying Debugging with Visual Studio 2010 Ultimate and IntelliT. I'm thrilled to be here. This is very exciting for me to get to be speaking at TechEd. So here is what I want to cover in the next 60 to 75 minutes, which is, I just want to give you a brief who am I. That's what I've been trying to do while we talked a little bit. And then I want to spend about 10 minutes covering some 2010 debugging features that you may or may not know about. So for example, there's your standard breakpoint, but did you know that you can also do things like conditional breakpoints? You can have a breakpoint that only triggers when you hit it every so often. I know you've probably dealt with data tips before, but there's a couple of cool things I've found that you can do with data tips that when I asked around this week, some people hadn't seen. So I want to show those off to you, and then we're going to get into IntelliT, which is the whole reason that you're here. And we're going to talk about how IntelliT works, and we're going to run some examples, and I'm going to show you the different features that you get out of the box with IntelliT, what you get by default installed, what you get that you can turn on. I'm going to then take you through the tester story, because IntelliT does not just help you as a developer when you're doing your debugging locally, but it also plays in if you're using the Microsoft Test Manager tools and the Test Runner tools. Your testers can do their testing, gather this IntelliT information, and then you, as a developer, can look at a log and be able to see what was happening in the application while the tester was running the test without having to rerun those tests yourself. I'm going to talk about IntelliT and Team Build because there's some tie-in to Team Build that you have to know about to really get the full power of that whole end-to-end story. And finally, I'm going to wrap up by putting you on the path for how you could create your own custom IntelliT events if you wanted to. There's some caveats there, which I will talk about. But, you know, it's always cool to understand under the covers how this stuff works and how you might be able to extend it. So real quick about me. I am Mickey Gousset. I am from Tupelo, Mississippi. So I have a question. First person to answer gets a prize. What is Tupelo, Mississippi most famous for? I heard Elvis back there. Who said it? Excellent, excellent. You need to come up here afterwards. I have for you, my good friend, a signed copy of Professional Application Lifecycle Management with Visual Studio 2010, signed by all 4 authors. Only 8 of these exist, mostly because we're never in the same place. It's completely self-serving because I did help write it, but I thought you might like a copy. So come on up here afterwards and I'll give it to you. Woohoo! So, a little bit about me. I'm an application lifecycle management MVP. Have been for about 6 years, which is really cool. I run Team System Rocks, which is my website that was devoted to Team System, is now more devoted to ALM. If you want to find me online, you can hit me up on Twitter, you can hit me up on Live Messenger, you can hit me up on Skype. In addition to talking, which I love to do, and hanging out with my family, which I love to do, I like to write. I did help write the book, Professional Application Lifecycle Management with Visual Studio 2010. And I also write an online column for visualstudiomagazine.com called Inside TFS. And I help co-host Radio TFS, which is our podcast that me and a couple other guys do around Team Foundation Server. So I'll tell you all about that later if you want to know about it. I'll be glad to sit around and talk about this stuff. But let's get started on what you're here for, which is to learn about debugging and to learn about IntelliT. So for those of you that know some of these debugging things I'm going to show in the next 5 or 10 minutes, just hang with me because we're going to get to the IntelliT stuff. But for some of you, if you're like me back when I was doing a whole lot of development, especially when I first got started, all I was doing when doing my development was I just set some breakpoints and, you know, hit F5 and tried to step through and dang it, I missed the wrong spot and oh great, I've got a loop of 50 things and I got to get to the 40th one, so let me go through it 40 times and finally get there. So I'm going to show you some of the things you can do some of these things were available before 2010 and some are available in 2010 from just a daily debugging standpoint with breakpoints and data tips that can help you out. So we're going to look at a concept called breakpoint labeling, which allows you to group breakpoints together. This makes it really easy if you want to disable a whole bunch of breakpoints at once or enable a whole bunch of breakpoints at once. We're going to talk about how you can import and export breakpoints, which is a great feature if I have set up all my breakpoints in such a way that I'm trying to figure out what's wrong with the system and I want Omar to look at it. Omar I can export my breakpoints, he can import them, the breakpoints are set for him and he can start doing the same kind of debug testing that I'm doing. I also want to talk about data tips. We've seen data tips before, and you've seen that they're pinnable. But what some people don't know is you can actually move them around the whole screen. And you can actually, once you're done debugging, can hover over a data tip and actually see the last value. And then I want to show you this conditional breakpoint ability, which is the ability to stop a breakpoint based off a particular condition, and the ability to stop a breakpoint based on how many times it's been hit. So I'm going to take a breath, try to slow down a little bit, and we're going to show you this demo, and then we're going to talk about IntelliT. And I know some of these windows appear a little small, but don't worry, because I have a fancy little utility that you've seen all week called Zoom It. Woohoo! So, I have a very, very complicated application to show you this breakpoints, because this is what I want to show you. So essentially, I've got my console app, and essentially I've got an array of colors, and I'm looping through those, and then I've got some methods that aren't really doing anything in write lines in these multiple methods. So essentially, when I'm doing my regular old everyday debugging, like if I wanted to debug what's going on in this loop, I set my breakpoint. I hit F5, and again, I have my windows down here showing me my local information. Here's my break, and I can continue through this. I can step through it. I can actually set a breakpoint down here on the method, and when I get to that method, I can do things such as skip over the method or skip into the method, that kind of thing. We've all seen that kind of standard breakpoint, debugging that we do every day. Now, one thing I thought was cool that's available in 2010 is this idea of breakpoint labeling. The idea being, if you have a ton of breakpoints, and let's say you've got a ton of breakpoints in different methods, and these methods logically group together in some sort of system, you can label those breakpoints so that you can affect them, turn them on and off through essentially one click. Now, the way you can do that is you can set multiple breakpoints here. Those lights are bright. I'm having trouble seeing my screen. And once I've got a breakpoint set, you can simply right-click on that breakpoint, and you have this whole breakpoint flyout window. One of the things you can do is edit a label. So this is where I can set a label. So I can say these are the method 2, or this is a method 2 breakpoint. I can then do the same thing, add another one. Now in this case, what you'll see is obviously that label already exists, so I'm just going to use that one. And just for consistency's sake, I'm going to come in here and add a label for method 3. And we'll call this method 3. So where do I see these labels? Well, you see these labels, stop my debugging, in the breakpoint window. So here's the breakpoint window. As you can see, one of the columns in my breakpoint window is this label section. Now what's really cool about this is you can do things such as, I can do a search for a particular label, if I can type, which I can't. Let's try that again. I can do a search for a particular label, which narrows this window down, which then allows me to say, okay, I want to disable all those breakpoints. Again, something quick and easy that you can do that allows you to manipulate your breakpoints without having to go and select each line and disable it. Okay, so you may have known about that one. I'll give you that. If I want to get this whole list back, I can simply just delete my search there, and I get my whole list back. But did you know about importing and exporting breakpoints? How many people in here import and export breakpoints? All right, some people do. Excellent. So, importing and exporting breakpoints is really pretty easy. All you do is, in your little breakpoints window, which, by the way, you can open by going to Debug Windows Breakpoints, I can choose to export all my breakpoints. And I simply choose a file. It makes an XML file, so we'll call this the breakpoint file. Now, this XML file is simply an XML file, but one of the things you have to remember when you import and export breakpoints is part of the code in the file is the line number where that breakpoint is. So it doesn't tie the breakpoint to, the piece of code that you wanted the breakpoint to run on. Instead, it ties it to a line number. So as you can imagine, if I then come up here and screw with my line numbers a little bit, and let's go in here and let's delete all these breakpoints. If I then import breakpoints from a file, you can see my breakpoints are completely off, all the way down. So my scenario of I want Omar to test things just the way I have them because I have my breakpoints that way only works if he's using the exact same file that I'm using that has stuff at the exact same line number. Otherwise, when you import those breakpoints, it's going to look different than you expected it to. So I'm going to clear all those. And I want to show you a couple of other quick things. So if we go back up, and I add a breakpoint here in my loop, if I right-click and I go to breakpoint, one of the other options that I have is hit count and condition. Let's do hit count first. Hit count allows me to specify when does this breakpoint trigger. Does it trigger every time, which is the default? That's what happens when you set a breakpoint. Does it trigger only when a hit equals a certain value, or does it trigger when the count's a multiple of a certain value? So let's go multiple of a certain value, and we'll say multiple of 2. So therefore, that means that we should hit when it's orange, we should hit when it's green, we should hit when it's indigo. Quick physics fact, by the way, this is the order of the colors in the rainbow, and the way you remember that is Roy G. Biv, just so you know. So, if I run my application again, then you'll see we hit on orange, we hit on green, and we hit on indigo, just like we expected. The idea here being you can make sure, especially when you're in a loop, and you're not worried about the value till you get to the 40th time through the loop, you can set your hit count to only trigger when you hit that 40th value. Simple, but some people, I didn't know this existed for a long time. So let's stop the debugging process here, and let me show you one other thing. You'll also notice on my breakpoint here, let me see if I can zoom in there. Notice that the icon changed. It's got a plus sign in it now. That's indicating that we've created a condition in that breakpoint for what makes that breakpoint trigger. And you can see if you hold the mouse over the breakpoint, it shows you what that condition is. In this case, it shows you that condition triggers when the hit count's a multiple of 2. By the same token, let's add a breakpoint back to this. And if we right-click and go to breakpoint, we can go to condition. And this is where we can specify a condition that has to be true for this breakpoint to hit. So how do we do that? For example, if I only want this thing to trigger when I hit the color green, I can use the variable name color because I've got it right there. And I can say dot equals, and ooh, look at that, IntelliSense. That's pretty cool. I can say that equals, and then I can specify what it needs to equal, which is green. And I click OK. And now we run this thing again. And bam, as you can see, it stopped on green. Woo! So, that's some of the breakpoint stuff that's available in the product right now that can help you with your current debugging, that may help you either speed it up or make it a lot easier to do some of the things you're trying to do. One of the other things I want to show you is a couple of things around data tips. So, if we run this, then you know, you've seen this before. You can hold your, there we go. You can hold your mouse over a variable. Data tip pops up, gives you the information about that variable. You can pin this out here. Now, a couple of the other things you can do is you can actually add a comment to this if you wanted to add a comment such as, this is the current color. And something I didn't know but thought was really cool is you can move this around. So I can drag this sucker anywhere I want to on my code so that then I can see that value when I'm debugging down in a different area. Notice there's a little pin value that follows it around here. And if I stop my debugger, that pin value is still there showing that there's a data tip here. And if I hover, it shows me the last value that data tip had from the last debugging session. One of the other things you can do with data tips that you probably already knew about, though, is you can actually modify the data tip while the code's running, so you can make changes to the data so therefore to see what happens to your code when you make that particular change. So that's what I've got that I wanted to show you around debugging features that you get out of the box. Here we go. So let's move on to what we all really are interested in, which is IntelliTrace. Had to fuel up. So, notice the spelling. The T is capitalized. If you spell it with a lowercase t, you're spelling it incorrectly. So, I'm serious. The T is capitalized. So, I'm going to ask again because I don't remember. How many people in here actually use IntelliTrace and mean to use IntelliTrace on a daily basis? Sweet. What do you think about it? Okay, fair enough. Excellent. So he said he needs to learn more about how to use it. And that's hopefully what you're going to get out of today. So, what is IntelliTrace and why do we care? So the idea behind IntelliTrace was to provide a way to do a couple of different things. So everyone in here has probably encountered the situation where the tester sends the stuff back to you and says, it's broke. Oh, my wife hates that. She says I'm supposed to say broken, not broke. So anyway, that it's broken. And then you do it on your machine, and what happens? It works. It works on my machine, and you kick it back to the developer, and you kick it back to the tester. The problem with that is, A, why is it not working for the tester but working for you? It could be the tester's using a different machine configuration. Could be the tester did it wrong. Could be the tester did it right and you did it wrong, but that doesn't ever happen. So the point is, there's multiple variables of why that could happen. IntelliTrace, one of the reasons it was designed is to make it where that scenario doesn't happen anymore. Essentially, it tries to get rid of the no repro scenario. And how does it do that? It does that by capturing debugger state information while the program is executing, while you're running your test, while you've hit that debug. When you've hit that F5 and you've gone into debug mode, or your testers are testing using Microsoft Test Manager, behind the scenes, IntelliTrace is capturing information. So, I figure the first question you're going to have is, what information is it capturing? Well, there's 3 different ways that it captures information. So it collects 3 different kinds of information. It collects what's called IntelliTrace events. So in Visual Studio 2010, there have been about 150 or so IntelliTrace events created. This is instrumentation that has been put into the product such that when you do a certain something, such as access a file, or access the registry key, or do an ADO.NET, access the SQL Server, it captures some information around that. Now, out of the box, you get about 150 different ones of these. I'll show you how you can see which ones they are. We're going to go through that. So that's one way information gets captured. And that's turned on by default. So anybody that's been using 2010 and running debugging, if you've not gone in and changed that value, then it's turned on and it's capturing that information for you every time. Now, not all the events are turned on, because as you can imagine, the more stuff you turn on, what happens? Performance. You could have a performance issue. But the events are the best way to quickly capture information and not necessarily have that much of a performance issue, if at all. The next way to capture information is through what's called, by turning on the calls feature. When you turn on the calls feature, IntelliTrace instruments the entry and exit of every method in your code. And it captures all the parameter information that got passed in, and it captures the results that come back out. So it's capturing more information for you to help you understand what's happening in your code. Now, there's one thing you're going to probably notice if you've been using IntelliTrace. So for those of you that have been using IntelliTrace, have you ever run IntelliTrace and then you go to try to look at a local variable at some point in time and it tells you IntelliTrace didn't capture that information? And that's a little annoying sometimes. Now, there's a reason for that, though. And the reason for that is this. If IntelliTrace captured everything that happened in your application and is putting it in a log file, you can imagine that that log file will get really, really big. And we don't want that to happen. So there's some things that happen, and I'll show you some ways you can control how that log file sizes. But the conscious effort was made to not just completely gather every piece of information. That said, if you are wanting to gather local variable information at a particular point in your application while you're doing IntelliTrace, set a breakpoint. If you set a breakpoint, then IntelliTrace will gather all the local information at that breakpoint. So that then allows you to see, the local variables that you care about at that particular time. So rather than me just tell you how it works, let's actually go and look at how it works. So we're going to open up a sample application, and that I've built that's really pretty simple, but the whole point is to show you how this thing works and show you what you can do with it. So let's flip back over, and we will close this, and we'll open up my fancy application that is really not that fancy at all. So, remember, I said out of the box, IntelliTrace is turned on. And you can see that by going to Tools, Options. There's an IntelliTrace section. And if you go to the General section, IntelliTrace is turned on by default. But it's only turned on for events, and only for specific events. And here's the events that it's turned on for. I've turned on a couple of more, such as console and file, because I'm doing a couple of things in the demo. But here is some of the events that you can capture information for. So for example, for file, it captures file access, close, delete. So it's turned on by default. So how do I actually see this working? You're telling me IntelliTrace is working. How do I know that it's working? Well, here's how you know that it's working. I'm going to take my little application, and don't laugh at my application, please. Okay, you can laugh. It's okay, because it's really, really simple. See? It's simple. I've just got 3 little buttons. I'm generating a random number. Woohoo! Check this out. I'm accessing from a file, but look at what's in the file, just so you know. You should read Professional Application Lifecycle Management with Visual Studio 2010. Oh, come on, that's a little funny. Okay, maybe not. So, and then I'm accessing another file, but nothing happened. Well, look over here. The reason I built this application this way is because I wanted you to see that there's this IntelliTrace window over here. How many people have seen that? How many people have messed with it? Or how many people have gone, I don't know what that is, the heck with that. There you go. So, it's gathering IntelliTrace information behind the scenes for you. How can I see that IntelliTrace information? I can break into the debugging session. At this point in time, the IntelliTrace window is showing me all the different events that it gathered information for. Now, what's cool about this is all of this is captured in a file, and I'll show you that file here in a second. But what's cool about this is, as I select these different events, it takes me in the code to where that event happened. So this allows me to just easily navigate through my code and see what's happening. Another neat way to use this, and this is definitely a way I suggest using it, is let's assume I've got like a really huge list of stuff. If I just want to see the exceptions that may have occurred while my application was running, even if you've handled them, maybe you still want to see the exceptions that occurred. In this search area, you can just type exception, and it will narrow the window down to just the exceptions that have occurred during that debugging session. You can select the exception, you can view the information, and then if you want to see the events that happened around that, you just remove the search tag. And it allows you to then be able to see the events that happened around it. So if you're wanting to look at your exceptions, drill down, find the exception you care about, then back out so you can see what was happening. Now remember, we're only capturing certain events. We're not capturing a whole lot of stuff. So therefore, this is going to be helpful, but there's going to be some other things that we're going to want to do to make it slightly more helpful. One of the things you'll notice is that it says, let's see if I can zoom in on that. Oh, did it wrong. IntelliTrace data has not been collected. It doesn't grab local variable information for you. It's not going to do that. If you want to grab local variable information, then you've got to actually add breakpoints. So let's come back up here and let's add a breakpoint into here. And let's add a breakpoint into here and into here. And we'll stop our debugging, and we'll run our system again, and we'll see what happens now that we've added a breakpoint. Boom, so let's add a breakpoint. Let's run through our little test again. And what you'll see, if I break in now, is I now have these debugger events that were captured. And the cool thing about these debugger events is that I can select them. And down here in my locals window, it gives me local variable information. So there is the return value that came out of that field that was set to that value. So for any of these events, you have the ability to access the locals window for that event or view call stack information for that particular event. So this is a good way to get started. This is lightweight. This isn't gathering, a ton of data for you, and you can control what gets gathered, but this is helpful. And you can go back and forth, and you can easily go, well, what's causing my exception here? Well, it's in that line of the file right there. Obviously, I'm doing a file access, and it can't find it. So you could run IntelliTrace over your application, just go through your app, and then come in here and look for any exceptions. And then maybe you could try to determine, well, that was supposed to happen, or maybe it wasn't. So you get those out of the box, and I'll show you, we'll go through in a second and look at some of the different events that you get. But let's see what happens when we up this a notch, and we turn on calls, and see what that gets us. So I'm going to remove all my breakpoints, and stop debugging. And we're going to go back to Tools, Options, and collect both IntelliTrace event and call information. So at this point, we're going to get the event information and the call information. And you'll notice that Edit and Continue is disabled when you're collecting call information. Something to keep in mind. So I'm going to click OK. And now if we run this again, there's F5. And we do my same little 3 clicks, and we break into it. Now, you'll see that we also have a calls view. So I can actually come in here, and I can still say, here's where my exception's happening. But now, I can flip to a call view to see the calls that occurred. This is basically an inverted stack of your regular call window. But here's some cool stuff you can do. Notice over here on the left-hand side, I have this new little area. This is called the navigation gutter. I can actually set my debugger context here, and now I have what some people refer to as VCR controls, if you're really old like me, or for the younger guys, it's TiVo, which I also have. But I can use these controls to navigate back and forth through the calls. I can also just select calls over here on the right-hand side and navigate through them. But at the same time, I can also go, OK, well, let's return to the area that called this method. So I can actually return. Or I can say, let's step back into here. I can go back to my IntelliTrace events information to where we clicked OK, to where we displayed the message box. And I can go to the calls view. So here is where we're going into get random number. And I can see all the values that were passed in. So I can see the parameter information that was passed in, and I can see the results that came back out. So the call information, when you turn on calls, it's going to gather the parameters for the calls, it's going to gather the return values. So again, it gives you just that much more information that you care about. And what's cool is all of this is stored in a file. It's all stored in a file. And depending on how you have things set up, I don't even have to have the solution open for it to then open up the code, to find the code and open up the code and show me where the problem is in the code. So you have this navigation bar that you can go back and forth with. You can go back and forth by selecting different calls in the call window. You can actually go back and forth by selecting the events. So you're navigating through your application. You're moving back to the history of your app without having to rerun your tests. So if you looped through this thing 50 times, you would have all that, you'd have that information in this call stack, or at least some of it, that you could use to debug without having to actually run the whole test again. So let's look at some of these IntelliTrace features. So if we go to Tools and we go to Options, we've already seen how you can enable IntelliTrace. We've seen how you can collect event information. We've seen how you can collect event and call information. I keep talking about this IntelliTrace file, right? Well, this is where you can control where that IntelliTrace file lives. By default, it lives in Program Data, Visual Studio 10, Trace Debugging. And every time you do a IntelliTrace, every time you run your debugging and IntelliTrace gathers this information, it creates a new log file. You can control the size of the log file by making it up to any of these values. And the log file is circular, so if you get to the bottom of the maximum size, it's going to go back to the top and keep going. So that's something to keep in mind. But what does this log file look like? Or where is it? Well, let's go see. So we're going to come back and look at these other things in a second. But we're going to hit Cancel. And I'm going to open up my computer. And we're going to go to C, Program Data, Visual Studio 10, Trace Debugging. And here are the different trace files that we've created so far. They have an extension of .itrace. As you can see, just the little bit that we did, right? What did we do? We clicked 3 buttons and did a couple of things. It's already made a 10 meg file. So you can imagine these things are going to get big quick, right? So now you're thinking, great, that's one more thing I got to worry about on my computer now. But it's not, because as soon as you close Visual Studio, it deletes all these. So if there's an IntelliTrace file, a debug session that you want to keep, you need to come into this directory and copy it out somewhere else before you close down Visual Studio. Because once you close down Visual Studio, it's gone. So I'm going to go back into Visual Studio here, and let's stop my debugging for a second. And let's actually close my solution. And let's open up one of these IntelliTrace files. That's not the one I wanted. I can't see. There it is. So, this is the IntelliTrace summary page. When you open up an IntelliTrace file, this is going to be the page that opens up. And some of the information that's contained on this page that you might care about includes thread information, and you can view detailed information about the particular thread. It includes exception information. So these are the exceptions, in this case I only had one, that were thrown when I was doing my IntelliTrace gathering. I wasn't running this as part of a test, so I don't have test data. It includes system information. Now, obviously, I'm testing this on my own system, so I know probably what my system requirements are. But I've got that information in this IntelliTrace file. And when I do IntelliTrace testing using the test tools, it's going to gather that system information for me as well. And then it also shows you the modules that it gathered data over, which are the different assemblies that it gathered data over. Now, check this out. I can come in here and I can select my exception. It shows me by the orange line where that exception occurred in the timeline of what was going on with my application. And I can double click that exception, and I don't have my solution open, but it opens up IntelliTrace, takes me to where that exception occurred, and finds the code file, takes me to where that exception occurred. And I don't have the solution open. So how did it do that? I'll tell you. You know those pesky little PDB files that get created every time you compile your application? How many people keep those? Wow. How many people would delete them because they're taking up space? How many people delete them just because they want to? Okay. So what do the rest of you do with them? Ignore them? They're there, but you're not really worried about them? The PDB files are super, super important. You need to start keeping your PDB files. And we're going to talk about a couple of ways you can do that, especially if you're doing automated builds. Because that contains all your debug information. It contains the mappings to local variables and your code. That's what allows this to happen in IntelliTrace. because it knows where my PDB file is, and it opens it up, and it's able to then correlate that back to where my line of code is for this exception. Let me show you what I mean by that. If I go back out to where I am actually running this code from, if I come out here, I've got a PDB file there. If I delete that PDB file, oh, and by the way, I can't do that yet because, look, when I opened up that IntelliTrace file, it put me in debug mode because that's what I'm doing. I'm debugging. The IntelliTrace file contains debug information. So I need to stop myself from being in debug mode. What I'm going to do is I'm going to delete this PDB, and I've also got to get rid of the one over here in the object folder. Pesky little PDBs. But now watch what happens. If I open up I'm still in debug mode. I still get all my IntelliTrace information. So I've got my event information, I've got my call information, but it's no longer showing me source code. This is still helpful, but you got to admit, it's not near as helpful as it going, taking me to my line of code that goes, here's your problem. So your PDB files are very, very important. And we're going to come back and talk about those again in a second and some things you can do to make sure you keep track of them. But at the end of the day, you've got to have your PDB files, and you've got to have the PDB files that were created with that specific version of your application during that compile time. You can't just take a separate set later and try to tack it on. It doesn't work that way. So, given that, stick with me. What have we looked at so far? We've looked at what IntelliTrace does, which is it captures all this information, puts it in a file. We can open this file. It's got event information. It's got call information. And we can navigate through that file, and it will actually take us through the lines of code that are related to the event or related to the call so we can see what's happening in our app. We can add breakpoints so that we can actually grab local data at those particular points. I forgot, because I got all excited, to finish showing you the options. So we got off on the file, right? We also have the list of events. So these are all the different events that you get out of the box with IntelliTrace for it to gather data over. So these are the top level categories, and then under each one you can see, like for ADO.NET, it's gathering execute, it'll trigger for execute reader, or it'll trigger for execute non-query. For ASP.NET, it triggers for those different values. And you've got stuff for data binding, environment information, files, registry. And you can turn these on as much as you want or as little as you want. Between events and calls, which one do you think is more intensive? Calls. Calls are much more intensive. So you want to start with events, and you want to turn on calls, if you're not getting what you need from the event standpoint. And finally, we have a modules list. Now, this modules list can be set up in two different ways. This can be an exception list or an inclusion list. By default, it's an exception list, and it says collect data from all modules except these. Why these? Because it's basically saying with the Microsoft.star, it's basically saying I'm not going to collect information over the .NET framework because you can't do anything about it anyway. So with, for example, third-party controls that you might have in your code, you may want to exclude them so that you don't collect the data over those third-party controls because you can't make a change to them if there's a problem in them anyway. Or you can make this an inclusion list where you include only these assemblies that you care about. And those are your basic options for IntelliTrace. Now, we've talked about how it works. We've seen calls and events. I want to move on and mention and move on to another part of the story, which is just as important. And that other part of the story that's just as important is the tester story. How many people in here use the testing tools in Visual Studio 2010? Okay. How many people know about them? All right, you all know about them. You all should be using them, but that's okay. So we have the Microsoft Test Manager, right? which can gather information or which can be used for setting up our test cases, setting up our test suites. And then you have the test runner that can be used for running our tests. So here's what I want to do. Before I flip over to my slides, I want to stop this. And I want to kick off a build. All right? I'll go back and show you some information. But I've created a build that's going to build my really fancy application, all right? So I'm going to right-click on it, and I'm going to queue up this build. How many people in here use Team Build? How many people do it with continuous integration? There you go. Good people. Good people. Even if you don't, you're still good people. So I am going to queue up my build to build my application. And while that's happening, and I'll go ahead and start up Microsoft Test Manager so that it's ready for me, I want to go back over here and discuss the quick scenario. So Microsoft did a lot of work with Visual Studio 2010 to make all this, to really bring like developers and testers closer together. All right? They put a lot of effort into the Microsoft Test Manager, a lot of effort into the test runner, and I think it's really, really kind of paid off. So here's the scenario. Scenario I have for you is, you have a nightly build that runs. The build runs, drops the information out there. The tester comes in, they run their test cases against that build. While they're running their test cases against that build, IntelliT is gathering information because it's been configured to. It's going to gather that information. The tester finds a bug, so they open up a bug using the testing tools. And part of the information that gets attached to that bug is the IntelliT file. You can also have a video recording of what the tester did, so you can actually see what they were doing, so you can go, see, you clicked the wrong button. But you have an IntelliT file attached to that. So what does that get you? The bug gets assigned to you. You go to open that bug, you see it has an IntelliT file. You open the IntelliT file. Because this was built with Team Build, because you set up Team Build to use something we're going to talk about in a second called Symbol Server, IntelliT is smart enough to know where the files are that you care about. So when you go to start debugging this, when you open up that IntelliT file, it's going to automatically go grab the source code that you need for handling that particular exception. Now, you're not opening the project, right? But it's opening up the source file so you can see the relationship between what happened. And then you can step back and forth through that IntelliT file, just like we did earlier. You've got all of the data that was captured. You're moving backwards and forwards to see what the tester did. And you're able to see, basically, you're debugging what the tester did while the tester was running his tests. So let's actually look at that, which I think is kind of cool. All right, so here we are. This is, well, let's go back. Let's make sure my build completed, which it did. So my build did complete. So this is Test Manager, right? And this is important. I felt like this was important to show because it is part of the story. So in Test Manager, I've got my test cases and my test suite and my test plan. Part of my test plan is for my manual tests, I've created a setting called Lots of IntelliT because I like IntelliT. So what does this get me? I can go look at this. What happens is you have different diagnostic data adapters that gather information when you're running your tests. And one of those data adapters is IntelliT data adapter. So you can configure what information gets captured. Just like you saw before, you can configure whether it's calls and events, the modules, what events get captured. Let me save this out. You can also take your test plan and associate it with particular builds. And I can even specify what build to use. So in this case, it's the build that we just did. Let me save this. So you have Microsoft Test Manager for planning out your tests. And you also use MTM to run your tests. So if I wanted to run this test suite, which consists of just this one test, I can right-click on this, and I can say Run. So this is going to take this manual test. So this is a manual test that I've created that's just got some basic steps in it. And it's going to gather information for me while the test is running. I'm not going to have it create an action recording, but I could. But I'm going to start my test. And for those of you that haven't seen the testing tools in action, Brian Keller has a great talk on it. Has a couple of great talks I think he's already done that you can watch on the Tech Ed site. But here's the manual test runner. So first thing it tells me to do is I got to start my application. Well, I'm going to go out here to where I dropped my application, which is in my drops folder, and start it up. And so that works, so that's going to pass. And then takes me to the next step, which is click the first one, and I should get a random number, and that worked, and that should pass. And then it tells me, click the next one, that worked. And then the tester clicks that, nothing happens. So they're going to fail that, and they need to leave a comment. So this is where you hope your tester leaves you a very detailed, specific comment, right? And they don't just go, failed. How many people see that a lot? Yeah, you don't raise your hand, but you do. So ultimately, my test has failed. So I'm going to end this test right here. I'm going to close this app because I don't care. And one of the things I can do in Test Manager is I can actually click here and create a bug from this information. So I'm going to create a bug, and I'm going to say this is a bug, so Mickey's app is not all that. And there's a lot of information that just got captured here, which I'll show you in a second. But we're going to save and close this bug. And ultimately, I'd probably assign it to someone, or I'd have a process in place that assigns that bug to someone. So I can get out of MTM now. And I can go back into Visual Studio, where as a developer, I'm looking to see what I'm supposed to work on. Or I'm looking through the product backlog or looking through the sprint backlog to see what there is for me to work on. So I've got a query I can use to show me information, such as my all bugs query, which shows me all the bugs. And there's the bug that we just filed. Now check this out. Some of the information in this bug is it shows me step by step what the steps were that the tester was using, and it shows me the comments that failed. It shows me system information for the system that the testing was running on. But the really cool part of this is there's an IntelliTrace file. Now, I've got nothing open, right? I've got no code open at this point. But there's an IntelliTrace file. I can double-click that IntelliTrace file, and it opens up. And as you can see, it shows the build associated with, let's see if we can zoom in on that. The build associated with this IntelliTrace file has symbol files published to this location. Therefore, that location will be searched when loading symbols. I have implemented something called Symbol Server, which we're going to talk about in a second, so that I'm storing all of my symbols for my builds in a particular location. IntelliTrace knows where that is because the build server, configured all that information for me. So I'm now able to do this, which is, there's my exception. I'm just back at my desk. I've got to work on this bug. I can double-click this. And boom, it opens me back up in IntelliTrace, which we've seen. We can navigate backwards and forwards. I can come in here and search for just exceptions. But since I double-clicked that exception, it actually opened up the code file and took me to the line of code that has the exception that the tester found. So I don't have to sit here and go, okay, I need to rerun the test, his test, and try to figure out how to do this. No, I can step backwards and forwards through IntelliTrace, and it shows me. This is cool. And admittedly, depending on your test, your IntelliTrace file could be huge, but you can use the searching, or you can use the categories box to narrow down what you see in the IntelliTrace field. You can find what you care about from an exception standpoint, flip over to the call view. But you have that ability now. If you've got your application running with TeamBuild, TeamBuild 2010, they made an effort to make it very easy to instrument your application using symbol and source server so that you're able to do this exact scenario, which is the tester creates a bug that has an iTrace file on it, and you're able to open up that iTrace file, and it takes you to the code that has the issue. This allows me to go, okay, there's the problem, because the actual problem is I've misspelled the file name. So now I can take this and go check out the code, go make a change, and fix the problem. Cool? Not cool? Okay. Cool. Some clapping. You don't have to clap, but that's okay. I was looking for head nods. So let me show you how easy it is to set your team builds up to make this happen. You ready? How many people think it's super easy? How many people think it's kind of easy? How many people don't care one way or the other? Fair enough. So, this is how easy it is to do. In my build definition, which is what defines my build, I set things like my build name, I set what triggers it, whether it's manual, continuous, workspace that I care about, the controller it needs to use, and where it needs to drop the information. And then I have this process folder. And in this process tab, there is a source and symbol server settings. This is already set to true for you by default. So all you do to implement symbol server is give it a path to a share. Hold that thought. So, symbol files, your PDB files, they're very, very important. They're used during the debugging process. And for .NET, they have things such as, file names in them, line numbers, local variable information. So what symbol server is a central location for storing your PDB files, right? Do not go to MSDN or TechNet and do a search for symbol server. You won't find it. It's not an actual product. It's not an actual something you install. At the end of the day, a symbol server is just a file share that you've set up to where information can be saved there. So again, to set up your symbol server, all you do is you create a file share, and you go into your build definition, and you tell your build where it's supposed to drop your symbol, drop your PDB files. So in this case, it's dropping them on my local machine. I can do this because this is all local. By the way, I'm using the one-up machine, the VM that you can download from Microsoft that has everything installed on it, TFS, Visual Studio Ultimate, that kind of thing. I'll take my really easy example and I'll put it out on my blog so you can download, but you can go get the latest version of the VM, and then you can do all the stuff that we're doing here. And you're more than welcome to email me, and I'll be glad to help you get that set up. So this is where it's writing stuff out to. So if I go out and look on my local host, I have a symbols folder here. This is where it's writing out my IntelliTrace examples PDB file. Oh, thank you. I was waiting to see who would catch that. So all I did was go to Windows Explorer. I've got a symbols folder there, and it writes it out to a PDB file. The way it relates the PDBs to the assemblies and whatnot is actually uses a GUID, so that's the GUID value. And then here's my PDBs. So this is where this is something you want to do because A, it gives you a central location for storing your PDBs, and it makes that whole process with the tester and everything just work. Now the other piece of this is something called source server indexing. And this is what you said when I had that source server is true. Source server is something that runs that will index your PDB information to contain where that stuff is in your version control system. So for example, it will say, okay, so this code file is located at this branch in this area. You use tf.exe to get it, and it instruments your PDB to make it where when I go to my IntelliTrace file and I want to go to that particular area, it knows how to go to Team Foundation Server, grab the information that it needs to pull that information down and view it. So that's the magic to make it happen. And the magic to make it happen is you say indexing true, and you give it a share. And that's all you have to do to make that scenario work. Thank you. So, what have we talked about? And I think I showed that to you already. But we'll go back and look one more time just to make sure we all got it, which is in my build file, that's where I set, wow, that's freaky. That's where I set my index servers to true and that's where I say the path to publish my symbols. So what have we looked at so far in the past 60 minutes or so? We have looked at IntelliT. We've looked at how it does the event information. We've looked at how it does the call information. We've looked at the different options that are available. We've looked at the iTrace file. Remember, the iTrace file is circular. Remember, those files do disappear whenever you close Visual Studio. I can prove that to you by going out here and going to Program Data, Visual Studio, Trace Debugging. And if I close Visual Studio, most of those are going to go away, but probably not all of them. Because, oh, no, they all went away. Cool. So you don't have to worry about cleaning this thing up. It cleans up on its own. We've seen how IntelliT ties into the tester story. The fact is, your testers can run their tests, and you can debug what happened in their test without having to rerun that test. Save yourself some time, get the problem fixed without having to go back to the developer and say, I can't reproduce it, because you've got enough information there to either reproduce it or show the developer that, or show the tester that there wasn't an issue. So that's IntelliT that you get out of the box, okay? And it works really well, and it works really nice. So my last little thing I want to show you before I take any questions that you might have, well, I got a couple other things I want to show you, are getting you started if you're really interested in trying to figure out how this whole IntelliT events thing works and how you could create your own. How many people like to know how things work under the hood? Yeah, that's what I thought. Me too. So, IntelliT ships right now with predefined events that it collects information over. Now, there's a framework that's there where you could create custom events, because there was a plan to do that, and it didn't make the cut. However, I'm warning you, really big warning, right? Whenever you do something that you know, is not officially supported, it's not officially supported. There's no documentation on it. You'll find one blog post on it. And how you do this now could change in future releases, so how much effort you want to put into this is up to you. But imagine this. If that doesn't scare you off and you really want to learn how to make this happen, that you can create your own custom events to gather event information over your code. So for example, you may have built some internal controls that you use in your organization. You could create custom IntelliT events to gather that IntelliT event data for your custom controls. Something like that. So how does this work? Now, I'm going to show you the steps to get you there, but we're not going to go all the way there. The steps to get you there is, there's one file that does it all for you, and that's the collectionplan.xml file. The collectionplan.xml file contains a list of all the events, which effectively are methods, that IntelliT can currently trace. Now, this file is loaded every time the Visual Studio is loaded at the very beginning. So if you make any changes to the file, you've got to reload that file. And essentially, there's 4 different sections you got to set. You got to set a category, which is that top-level category that we saw. You've got to set a module, which is the assembly that IntelliT is going to look over to find this information. And then you have to create what's called a diagnostic event specification, which specifies the method that you want to trace. And that's what does the heavy lifting. That's also going to be the hardest part of this to write. So let me go show you just a little bit of this, just to kind of tease you just a little bit. So, if we go back to C, and we go to Program Files, Visual Studio 2010, Team Tools, Debugger Tools. The other thing I want to show you is, in the Debugger Tools right here, we have an IntelliT executable that you can run from the console. So you can actually take this, and if we open up a command prompt, we do a cd. You can run IntelliT from the command line. So you can do things such as start up a log in the background, start up a logger against a particular application, things like that. But if you go into here, you can see where I've been messing with the collection plan. Here's the collectionplan.xml. If I open that up in Visual Studio, It's just an XML file, right? And if we start drilling down to the section that you're going to care about, if you really want to start doing this, it's the trace point provider section. So the first thing you have to set is a category. So this is going to be that list of categories that you see in the options section, right? So we'll just do a quick little cut and paste here. And we'll give this an ID, and we'll call it Mickey, and we'll call it category.Mickey. You can call it pretty much anything you want to. And for my top-level category, we'll call this Mickey Rules. We'll save our collection plan. Let's close Visual Studio. Let's open Visual Studio back up. In fact, we'll reopen our collection plan while we do it. And if I go to Tools, Options, and I go down to my IntelliTrace area, IntelliTrace Events, there's my Mickey Rules. So I've set my top-level category. That's great. Now I got to do the actual hard work of making this thing do events. And where you do that, oh, I hit the wrong key. Let's drill back down into this file real quick. If you want to see how this works under the covers, is you have the category section. You have the module section where you specify the assembly that you want to look over. And then you have the diagnostic event specification, that you have to create one of these for each of the methods that you want to gather data for. Now, if you want to kind of correlate this back and forth, if we do a look for file.access, this is the diagnostic event specification for our file open. How do I know this? Because if I open up another version of Visual Studio and I go to my example, oh, that's not good. And we run my example. And we do some file access, and we break into IntelliTrace. Then you can see, if we look at the file access information, that it says file, it says access, and it shows you the file name, and it says initializing a file stream to the path, and it shows you the file name. If I go back over here to my collection plan for this diagnostic event, there's the access. There's where it's saying access and the file name. This is where it's saying initialize a file stream to the path, and then the path that it's trying to open. So that's how you can delve into here and start trying to figure out how to build your own custom event if you want to. You don't have to. The events you get out of the box work really, really well. However, you do have that capability if you want to get into the covers to see how this works. And if nothing else, this collection plan.xml file is just kind of neat to look through to understand what makes IntelliTrace do what it does as far as event collection. So there's a couple other things I want to tell you. I made a couple of quick notes so I wouldn't forget. What does IntelliTrace work on, right? So based off of what I pulled off of MSDN this afternoon, it works for VB and C# and .NET 2 through .NET 4. You could do ASP.NET, WinForms, WPF, Workflow, and WCF. If you've installed Visual Studio Service Pack 1, you get 64-bit application support as well as SharePoint support. So you get all of that information. I had someone ask me earlier, does it do Silverlight? I'll find out that answer for you and I'll put it up on my blog. So, wrapping up, this is what all we've covered in the past 65 minutes, which is a lot when you think about it. You learned who I am and where I'm from. Don't forget your book. You learned the basics of how IntelliTrace works, both the calls and the events, and how you can move back and forth and navigate back and forth, and how with the calls you have that little navigate gutter that you can move back and forth with. We learned about iTrace files, what they are, how big they can get, how we can open those iTrace files up, how we can then view the information, double-click something in the iTrace file, and it takes me directly to where that exception is. We learned the tester story, how the tester story works, how the testers can gather IntelliTrace information when they're running their tests, and then I, as a developer, can just take that iTrace file from the bug. And we learned how to make that happen by turning on Symbol and Source Server in Team Build. And finally, I showed you a little peek under the covers for how IntelliTrace works for building custom IntelliTrace events. Other stuff you may care about which is there is a hands-on lab for using IntelliT. And shoot me an email. Hit me up on Twitter, shoot me an email. You can find me on Live Messenger. You can find me on Skype at Mickey_Gousset. I love doing community stuff. I love answering questions. Sometimes it may take me a little bit, but if there's something I can help you with or just a question you have, please, please contact me. Hit me up through the blog. It doesn't matter. I would love to try to help you with whatever you need so that you're successful both with IntelliT and anything else related to ALM and TFS. So please keep that in mind. So if you go download the slide deck, then you get all these different track resources that you may be interested in. There's a bunch of other resources you see in this slide in probably every show you've gone in. One thing I do ask is please, please go fill out your evaluations. All right? A, you can apparently win some cool stuff, and B, it lets me know how the talk went, the things you liked, the things you didn't. So please go fill out the evaluation so I know how things went. So given that, and if you're doing the little tag thing, there's my tag. Given that, I've still got 8 minutes or so on my green bar, so I'm going to ask if you have a question to please get in a mic so that it gets recorded. Don't hate me for that. I know you're raising your hand. I'll let you go first, but hurry up to the mic and knock people out of the way. If you don't, please go fill out your evals. I hope you have a great session. You can find me at the TLC, or you can contact me through email. I'll meet you for breakfast, lunch, do whatever.
Yeah.
Thank you. Thank you.